First knowledge point, preparing sulfur dioxide. When we studied chlorine element, we discussed the preparation of chlorine gas. So what about sulfur dioxide? Our lab equipment often relies on preparing sulfur dioxide. When we talked about sulfur dioxide earlier, we discussed using sodium sulfite and concentrated sulfuric acid to make sulfur dioxide. This should be no problem for everyone, so let's write out the equation directly. Sodium sulfite and concentrated sulfuric acid under heating conditions produce sodium sulfate, sulfur dioxide, and water. This is no problem, right? What's the key point? Heating. So during the exam, if they test you on using the apparatus, the first key point is, since it's a solid liquid mixture, therefore the test tube mouth should tilt slightly upward. If you tilt it downward, all the liquid will flow out. Everyone can understand this, right? So the test tube mouth tilts slightly upward. Second, this reaction requires heating with an alcohol lamp. Okay, why use a removable copper wire? Because it lets you control when the reaction starts and stops. Okay, next, since there's a heating reaction, we must consider the alternative reaction. Does the alternative require heating? No, it doesn't. The alternative reaction is solid liquid mixture, no heating needed. We use sodium sulfite and concentrated sulfuric acid. They react directly to produce sodium sulfate, water, and sulfur dioxide. Answer me, is this an oxidation reduction process? No, it's strong acid making weak acid, right? Concentrated sulfuric acid and sodium sulfite produce sodium sulfate, water, and sulfur dioxide. It's a metathesis reaction. Okay, so for these two reactions, do we need an alcohol lamp at the bottom? No, because its advantage is not needing to light an alcohol lamp. Okay, next, drying. We've discussed this before, right? We talked about concentrated sulfuric acid. Concentrated sulfuric acid can dry what? Sulfur dioxide. So for this reagent, we can use concentrated sulfuric acid. Impurities in, constant in, short out. Okay, next, collection. Since sulfur dioxide's density is greater than air's density, we can collect it using upward displacement of air. This is no problem, but we can also collect it by displacing liquid. Think about carbon dioxide. Besides upward air displacement, I can also displace what? Saturated sodium bicarbonate solution. Because carbon dioxide doesn't dissolve in sodium carbonate at all, the volume of liquid displaced equals the volume of carbon dioxide. Right, so by the same logic, if I want to collect sulfur dioxide, what should I displace? I won't write the label. I'll write saturated sodium bisulfite solution. This knowledge point was tested in the Beijing College entrance exam. For the liquid displacement method, since you're displacing a solution, it should be short tube in, long tube out. You need to know this. Upward air displacement, long in, short out. Liquid displacement, short in, long out. This pushes the water out through the right side tube. Okay, sulfur dioxide is toxic, right? Toxic. So for exhaust gas treatment, what do we use? We use sodium hydroxide solution. Sulfur dioxide dissolves in sodium hydroxide solution to form sodium sulfite. This is the key test point for our entire exam. It's about choosing the right apparatus and how to use it. These are frequently tested topics. All right, next, let me add another knowledge point for you. You should actually already know this one. We covered this before when you practiced problems, but now that class is over, we should be able to recall it. Let's recall this property. Sulfur dioxide turns purple litmus paper red. Does it fade? No, it doesn't fade. What property does it have? Acidic oxide properties. Good. Next, dilute sodium hydroxide solution that was originally red. How does it fade? Does it fade because sulfur dioxide bleaches it? No, it's also because it's an acidic oxide that can react with alkali, forming salt plus water. So the alkalinity weakens and the red color fades. Acidic potassium permanganate solution, permanganate with positive 7 valence manganese, has oxidizing properties. Sulfur dioxide with positive 4 valence sulfur has reducing properties. A redox reaction occurs and the potassium permanganate solution fades. The property is due to its reducing nature. Next, chlorine water. 0 valence chlorine has oxidizing properties. Sulfur dioxide has reducing properties. Also, chlorine water fades. Reason, reducing properties, magenta fades. I won't explain this one again, okay? This fading is because of what? Because of its bleaching properties, barium sulfate produces a pale yellow precipitate. It's because -2. Valence sulfur has reducing properties, and +4 valence sulfur dioxide has oxidizing properties. It reacts with hydrogen sulfide because of its oxidizing properties. All right, so up to this point, we finished covering the overall framework of sulfur for you: elemental sulfur, sulfur dioxide, sulfur trioxide, dilute sulfuric acid, concentrated sulfuric acid, preparation of sulfur dioxide, testing for sulfate ions. We've covered all the key knowledge points, so that's basically it for our main content. In the next lesson, we'll cover the final lesson in the sulfur series. Since its valence changes quite a bit, next lesson we'll discuss the conversions between different sulfur compounds. Okay, so that's all for this lesson.